What's up, geometry? Thanks for tuning in for another episode of Math with Mullins. Today we're going to be looking at lesson 4.1, translations. When we're looking at 4.1 translations, we're going to focus on how can you perform translations and how would those look like written. And then can you solve real-life problems in solving those compositions? Let's go ahead and get started. The first thing we want to make sure we understand is what a vector is. A vector is a quantity that has both direction and magnitude or size. And this is going to be how we understand the ways that we're transforming our figures. This is honestly what we're going to be using throughout our unit of transformations. The next thing we want to look at are different types of vectors. So this diagram will show a vector and it shows the initial point or the starting point is letter P and the terminal point or the ending point is letter Q. The vector is now named P to Q, which is read as vector PQ. The horizontal component of PQ is 5 and the vertical component is 3. So the component form of a vector combines these horizontal and vertical components. So the component form of vector is what looks like these two arrows, 5, 3. 5 meaning right, 3 meaning up. If you had a -5, that would just mean go to the left. And if you had a -3, that just means going down. We're going to try a few examples, but before we do, we're going to talk about a few different transformations. First of all, a transformation is a function that moves, which is what we're doing today, or changes a figure in some way. Later on in our chapter, we'll do changes like with dilations. Today, we're just moving it. The image is the new figure. The pre-image is the original figure. A lot of the times we'll see like A, B, C could be a triangle, and the new figure would be A prime, B prime, C prime. Today, our main focus is a translation, and that just means we're going to move every point in the figure the same distance and in the same direction. Before we go on from this slide, just make sure you have these 3 or 4 items written down, and when you're ready to go on, go ahead and click play. All right. Going forward, it says the vertices of triangle ABC are A, 0, 3, B, 2, 4, and C, 1, 0. Translate the triangle using the vector 5, -1. So first we understand that 5 is going to the right and 1 is going -1. It means to go down. The main thing we would want to do here is probably write our first pre-image first. The pre-image meaning that's the original figure. So let's do that first. 0, 3 is where A is. 2, 4 is where B goes. And 1, 0 is where C is. So here is A, B, and C. Notice I didn't put any prime on there. Sorry for the interruption. All I did was I connected my points to make triangle ABC, and now I'm going to translate the triangle using vector 5, -1. 5 means going to the right 5, -1 means down. So I'm going to start with point A. So A means going to the right. So I'm going to show your red dots here. We're going to go 1, 2, 3, 4, 5, and then down 1. This is going to be my new point A, so I'm going to label that A prime. That now means I've added 5 to the 0 and subtracted 1 from the 3, which means I'm now at 5, 2. Okay, so that's another way that you can picture that. You're just adding +5 to the x values and subtracting 1 from the y's. Let's do letter B. Going to the right. 1, 2, 3, 4, 5, down 1. Here is my B prime. Again, adding 5 means that is 7, 3. Add 5, subtract 1. C prime will be 1, 2, 3, 4, 5. Down 1 should end up down here. That should be at 6, -1 for C prime. Connecting all my points together, and I now have my translated image. Next up, it says write a rule for the translation of triangle ABC to triangle A prime, B prime, C prime. All you need to do is just pick a point and figure out its new point. So here we are at A, and it looks like I'm going to the left first. So I always want to start with my X movements, which is left or right. So do left or right, then up or down. Okay, so to the left, I go 1, 2, 3, 4. So I just went left 4, and then I go up 1 to get to my new image. So that means you can either write this as a vector. So you would say vector, and you've got your two symbols. I went to the left for, so that's -4, and then +1 means up. Or you can write the rule like this, and this is what you're actually going to see more of. X comma y has now been translated as x minus 4 comma y plus 1. This just means left 4 and then up 1. Okay? I didn't write the rule for this previous one, but if you wanted to write the rule, this would be x comma y, and then to the going forward it'd be x plus 5 and then y minus 1. Okay? So sorry about that. Graph quadrilateral ABCD with these vertices, -1, comma 2, -1, comma 5, 4, 6, and 4, 2, and then its image after the translation of xy is going to x plus 3. That means right 3, and y minus 1 means down. Okay, so let's go ahead and plot the points first of our pre-image. So here is the pre-image ABCD. Now I'm going to translate each point. All you have to do is start with 1 point. I'll start with A. We're going to go x plus 3, which means to the right 3. 1, 2, 3, and down 1. So that means A prime is now at 2, comma 1. B prime to the right 3. 1, 2, 3. Down 1 ends up right there in the middle of the old, or the pre-image. My B prime is now at 2, comma 4. C prime to the right, 1, 2, 3, down 1, makes C prime at 7, comma 5, and D prime going to the right, 1, 2, 3, down 1. I'm getting D prime at 7, comma 1. All that's left is to connect your dots the best you can to show your pre-image and now your image. The next portion we're going to see is rigid motion and some postulates. Rigid motion is a transformation that preserves the length and the angle measurement. This is also called isometry. When we see this is mainly you're not making the shape any bigger or smaller, so this is a good way to show a translation. A postulate 4.1, the translation postulate can be stated as this: a translation is a rigid motion. That just means you're moving it, you're not changing the length, you're not changing the angle measurement. This is called isometry. Next up we have the composition of transformations. That's when two or more transformations are combined to form a single transformation. So we're going to see that in just a moment. So that theorem we could see is theorem 4.1, a composition theorem. This is the composition of two or more rigid motions is still going to be a rigid motion. Before we go on, just make sure we have the highlighted portions filled in our notes. Sorry for all the interruptions. Let's keep going. Graph RS with endpoints R at -8, comma 5 and S at -6, comma 8, and its image after the composition. So we're going to actually have two different translations. When we do our first translation, we're going to name that R prime, S prime. But then we do our next one, it'll be R double prime, S double prime, to show you that it's a double copy. Okay? So R is at -8, comma 5, and then S is -6, comma 8. Okay? So we're going to go ahead and connect those dots. Now let's go ahead and do our first translation. X plus 5, y minus 2 means I'm going to go the right 5. 1, 2, 3, 4, 5, down 2. Here's my R prime. S prime would be to the right 5. 1, 2, 3, 4, 5, down 2. S prime is now here. So I've got -1, comma 6 for S prime, and then for R prime I have -3, comma 3, and I'm going to connect those points. Then it says, now I need to translate again. So now when I translate again, this will be the R double prime, S double prime. X -4 or X minus 4 means to the left 4. So 1, 2, 3, 4, and Y minus 2 is down 2. So our double prime is now at negative 7, comma 1. Then S prime, starting where I just did my image, I'm now going to do the next image. Negative 4 means 1, 2, 3, 4 to the left and down 2. This point will now be my S double prime. Go ahead and connect those points and you're done. Rewrite the two translations as a single translation. So that just means how can I go from R to R double prime? That looks like I'm going to go to the right one. So that would be X. Well, let's start here. X comma Y will be changed to X plus 1, comma, and then as I went right one, I go down 1, 2, 3, 4. So that would be Y minus 4. That's one way you can visually see it. The other way you could look at it is how do your X's change? I have a positive 5 and a negative 4. That means that's a positive 1 X change. And a negative 2 for the Y's. That automatically produces that negative 4 for the Y. That is going to conclude our notes today on 4.1 translations. Thanks so much for tuning in.